Hello there, you're welcome to Biology Lectures with Akerele Olademeji Philip. On today's edition, we'll be looking at some questions on OCR A-Levels 2021. This question says, Figure 23.1 shows a spirometer trace of a student at rest breathing for 1 minute. The trace shows a period of resting followed by a maximum inhalation and exhalation. For some major reasons, you need to understand like everything on this graph. Really, there's a lot of information to pass on or to know for you to be able to answer these questions properly. Number one is all this breathing, inhaling, exhaling, like all of those ones is called tidal volume. Tidal volume is like the normal rate of breathing. So all of this is tidal volume. All right. Then when the person is tidal volume ends here, that the person decided to breathe in forcefully or breathe in like with more force, we call that inspiratory reserve volume. I mean that means the person is, let me use another color for that. The person is breathing like extra air. That's what you have here. So I think I should just change the color actually. Like this is the that then it comes back to normal like this. Let's now assume the person decided to like exhale like extra air after the normal tidal volume, which is around here. So that is going to be this one. So let me use another color for that. Say I use green. So this here is called expiratory reserved volume. This is the extra air after normal volume, normal tidal volume. So this is extra one, extra. That's called inspiratory reserve volume. That's the extra way of exhaling, so of inhaling, I mean to say. Then this is extra inhalation, so to say. So that's called expiratory reserve volume, so to say. All right, you would soon understand why I said a lot of those things shortly, so I'll come back to that. Now it says here, explain why there's a downward trend in the trace. Okay, of course, I think it's referring to this one, that downward trend. Well, basically it's because you can say there is decrease of air in the lungs, like because the person is exhaling, usually due to exhalation. You can say more carbon dioxide is forced out of the lungs because it's an extra air the person is forcing out, so to say. All right, now it says calculate the mean resting calculate the mean resting breathing rate. Okay, that's more like okay. But the breathing rate, actually the resting period are this ones, one like inhalation, exhalation, inhalation. So you count like this is one breath, 1 breath, 2 breath, 3 breath, 4 breath, 5th. Sorry, let me say that again. 1, 2, 3, 4, 5, 6, 7, 8, and 9, I suppose. Now you're supposed to know the number of breaths. So we have 9 breaths. All right, then how many seconds does it take for that to happen? So we have 1, 2, 3. Let me make that bigger. 4, 5, 6, 7, 8, 9, 10. So this is 10. So this is 10. This is 20, 30, and 40. then 41, 42. I mean, taking it to this one here. So that means for us to calculate, that's going to be the number of breath divided by the time, or the second, times 60 in a minute. So that's 9 breaths divided by 42 seconds that we counted. I mean, the 42 means the 40 seconds we counted from here to here, like this whole part, times 60. If you do that in your calculator, let me punch mine here. It should be a few seconds, please. It should be 9 divided by 42 times 60. That's equals to 12.85. So what we have is 12.85 breath per minute. Or well, sometimes you could probably approximate it to 13, but either way is correct. Either you approximate this or just keep it this way, 13 breath per second. Either of that is correct. All right, so moving on, it says here, using the trace in figure 3, state the vital capacity. Wow. Now vital capacity is the, let me write the formula here. Vital capacity is written as VC. VC is the tidal volume. That's the normal breathing rate plus inspiratory reserved volume plus expiratory reserve volume. So we have to get all of these value from that graph. Now it's funny that like we only have one value here, and that value is 0.5 dm cube. So it means that our tidal volume, which is, let me get this off, our tidal volume majorly is actually the resting phase. This one's is that's 0.5. Now what you need to know here is that you need to, for better understanding, if this from here to here is 0.5, this is going to be 1.0 dm cube, 1.5 dm cube, then 2.0 dm cube. All right, then this is going to be 2.5. Now what you need to do is the excuse me, I'm trying to remove this now. Okay, good. Now at this point here, this point, if you trace this out, that's about 2.2. So this is 2.2. So for you to get the inspiratory reserve volume, which is from here, the extra air that you breathe in after the normal breath, is going to be, that's going to be from this, going to be this, from this distance, like this distance, this distance. So what you're going to do is you're going to 2.2 minus, so together it's going to be 2.2 minus 0.5. So it means this 2.2 is from here and this 0.5 is from here, because you're calculating, you have to subtract from here and here. So because we just want to get, excuse me, we just want to get the distance here to here only. All right, so if you do that, your answer should be, I'm punching my calculator now. It's going to be 2.2 minus 0.5, so that's 1.7. so the volume of inspiratory reserve volume is 1.7 dm cube. All right, then the next thing is, you know, we're supposed to look for expiratory reserve volume, which is the extra air the person like still exhaled after normal breath, which ends here. So to do that, the same thing, let me get this off, the same thing. Okay, this is so this is going to be 1.0, because it is from here to here is 5, is 0.5. This is going to be 1.0, 1.2. No, this is going to be 1.5 anyways. So it means from here where it ends, let's just say here, like that. That means from here to here, that's 1.3. Am I right? Yeah, because this is 1, 2. So this is 1. This is 1, 2, 3. So this is going to be 1.3. Now, what we are looking for is this. Sorry, excuse me. What we're looking for is the distance from here to here. Just that distance. Just that distance. And to do that, what do? We subtract. To do that, it's going to be 1.3 minus 0.5. So that means we are subtracting just the distance, this distance, I'm tracing it out again, this distance from this whole distance of, subtracting this whole distance. So this place to this place, that's the whole part. Then we are now subtracting this from this whole part. All right, so that's why that's what it means. I hope you get the point. So it's going to be 1.3, excuse me, 1.3 minus 0.5, and that is 0.8. So our reserved volume, expiratory reserved volume, is 0.8. So coming down here, so the tidal volume is 0.5 plus what's inspiratory reserve volume, that's 1.7, 1.7. Then what's expiratory reserve volume, which is here to here, is 0.8, 0.8, all in dm cube. And if you do that, trying to do that now, is going to be 0.5 plus 1.7 plus 0.8 plus 0.8. That gives us 3 dm cube, or 3.0. We could just make it like that, 3.0 dm cube. And the question says we should give our answer in centimeter cube. So basically it means 3 times 1000, because 1 dm cube equals to 1000 centimeter cube. So that's why we're having that. So it's going to be 3000 centimeter cube. All right, you might want to just go back to this part, this whole thing, like just that, why we have IVR, which is IRV, which is inspiratory reserve volume, that's the extra air. IER is the, so ERV is the expiratory reserve volume, that's the extra air you breathe out. Hope this makes sense. All right.